Yeah, good evening, children. Good evening, Sai Smriti.
Good evening, ma'am.
Yeah, good evening, Anintika.
Good evening, ma'am.
Good evening. I'm actually starting from the introduction in today's class. I don't know, it was very new. I couldn't download the recording of the last session. And since many of them are not attending the class due to exams at school, I need to start off from the beginning. All right. So you don't have to write anything. I'll tell you when you have to start writing. So today's class will mostly be lecture from my side. You will not be writing anything. I'll give you further instructions. All right. So don't take down anything now. Wait for my instructions. So this is a new chapter, all right, from the NCERT maths textbook, and it's called Algebraic Expressions and Identities. All right. So before we start working the questions from the exercises, we need to get familiar with certain terms in this chapter. So to begin with, what are constants and variables? All right. So a constant is a symbol that has a fixed numerical value. A constant is a symbol and it has a fixed numerical value. Now see, this is a symbol. It's a symbol, no? It's a kind of a drawing, right? When I do something, it's a kind of a drawing. It's a symbol. And it has a fixed value. And that fixed value is -7. See, this is a symbol. The kind of a drawing, it's a symbol. And it has a fixed value, which is 5/4. 100 is a constant because it has a fixed value. Pi is also a constant because it has a fixed value. All right. So constant or constants are symbols that take a fixed numerical value. A variable. A variable is also a symbol that can assume any numerical value. It's a symbol. So both constants and variables are symbols. Constants have a fixed numerical value. A symbol that has a fixed numerical value is a constant. A symbol that can assume any numerical value is a variable. So variables are normally represented using the lowercase in the English alphabet. Okay. So for example, X, Y, Z, A, B, C, so on. Now coming to what is an algebraic expression. Okay. So which is a part of the name of the chapter, algebraic expressions and identities. So what are algebraic identities? We'll see in the second part of the chapter. So for now, what is an algebraic expression? So an algebraic expression is a combination of constants and variables. Is a combination of constants and variables connected by some or all mathematical operations. Online students, I've shared my screen. It's visible, right?
Yes, ma'am.
All right.
Yes, ma'am.
Yeah, thank you. Yeah. So an algebraic expression is a combination of constants and variables connected by some or all mathematical operations. So we know we have 4 mathematical operations: plus, minus, meaning addition, subtraction, multiplication, and division. Now let's have a look at some algebraic expressions. We'll see how they're constructed. So look at this: 4x minus 5. 4x minus 5. Now 4x means 4 into x or 4 times x. 4x means 4 times x, 4 into x minus 5. Okay. So now here you will see the constants 4 and 5. 4 and 5 are the constants. And the variable is x. All right. And the variable is x. Look at the next one. This is an algebraic expression. It's made up of the constant 7/8. With the sign, it is -7/8. 7/8 minus 7/8, constant, right? Because it's a fixed value. The variables are a and b. A and B are the variables. So here this algebraic expression has two variables. This algebraic expression has two variables, A and B. And the constant here is 7/8 or minus 7/8. Look at the next one, xy minus z. So here you have only variables, x divided by y minus z. So you can see that in these examples of algebraic expressions, we find variables, constants connected by the mathematical operations, plus, minus, multiplication, division. All right. Okay. Now, how many terms does this algebraic expression have? Two terms. Because the separator, what separates the terms? What separates the terms? The plus sign or the minus sign? The plus sign or the minus sign separates the terms. All right. So you can see here. Now you can see the minus sign here. So before this we have 4x and after this we have 5. So 4x and 5, they are two terms. So this algebraic expression has two terms, 4x and 5 connected by the minus sign. This algebraic expression has three terms, A, B and 7/8 connected by the signs plus and minus. This algebraic expression has two terms, x by y and z connected by the minus sign. I think I missed a comma here. Okay, so this algebraic expression, again, two terms separated by a minus sign. Okay, three terms, 1, 2, 3 terms. You can see the separator, minus and plus signs. All right. And finally, you see A, B, C, D. That's only one term because you don't see the plus or the minus sign there. So A, B, C, D is only one term. If it was A plus AB plus CD, plus CD, then two terms because AB is one term, CD is the other term, and the terms are separated by a plus sign. If it is A plus B minus C minus D, then 1, 2, 3, 4 terms. Because we can see the separators. Between A and B, there's a plus sign. Between B and C, minus sign. Between C and D, minus sign. So plus and minus, these signs are the separators. All right. So in ABCD, we don't see the separators plus or minus. So there's only one term. ABCD is only one term. So now we need to understand another term called polynomials. All right. So constants, variables. Now these make an algebraic expression, a combination of constants and variables connected by some or all mathematical operations is an algebraic expression. Now next, polynomial. What do we understand by the term polynomial? Okay. Okay. So this is understanding this term polynomial correctly for the first time is very important, because when you don't get the meaning of this term correctly, we are confused in many places, then you have to unlearn and learn it correctly. So get me right. Listen to me. You may already have some version of a polynomial. You may have understood the term polynomial using the first part of the word poly. Poly means many. So polynomial means many terms makes a polynomial. No. All right. Poly is many. Poly means many. But polynomial does not necessarily mean an expression with many terms. No. So then what is the correct understanding of the term polynomial? A polynomial is an algebraic expression. All right. But every algebraic expression need not be a polynomial. All cats are animals, but every animal need not be a cat. Likewise, a polynomial is an algebraic expression, but every algebraic expression need not be a polynomial. So then what is this polynomial? Now, to understand or to identify polynomials from algebraic expressions, See now, supposing, there's a place where many animals are stationed. Supposing, okay, there's a place where many animals are stationed. How do you identify a cat or a dog? So you know how it looks like, or you might look out for its whiskers or the way the ears look like, or the furry tail, whatever. So there are some features that distinguishes a cat from a dog. All right. So in the same way, so like how animals are stationed in a place and you can identify a cat, a dog. Similarly, among algebraic expressions. Okay. So like animals, we have many algebraic expressions. From these many algebraic expressions, how do you select the polynomials from them? Because every algebraic expression need not be a polynomial. So which of the algebraic expressions are polynomials? How do you identify polynomials? Now, let me write an example. Yeah, Aishwarya.
Aishwarya,
Deepthi is already given the instruction to join this class and complete her work. Okay. Is it regarding that? Okay, tell me.
Well, I accidentally joined late, so I don't know what is going on. Like I
Yeah,
have to go.
we are continuing with the chapter. Just continue listening. That's all.
Okay.
You have not missed anything.
Okay.
Okay. Yeah. Now look at this example. X to the power 5 minus 4x cubed plus 7. All right. Now you can see the variable x. You can see the variable x. What's the power of the variable x? 5, which is a whole number. What's the power of the? Okay. Before that, how many terms are there in this algebraic expression? 1, 2, 3 terms. Okay. 3 terms. This algebraic expression has 3 terms. Now, in the first term, the variable is x and its power is 5, which is a whole number. The power 5 is a whole number. In the second term, the variable again is x and its power is 3, which is a whole number. Now, 7 is a constant. You don't see any variable attached to it. So ignore 7. Forget the constants. We are concerned only about the variable or the variables involved in the expression. If the power or the powers of the variable or the variables involved throughout the expression are whole numbers. Okay, if there is only one variable, its power should be a whole number. If you find different variables or the same variable x in different terms, everywhere the power of x or the power of the variable must be a whole number. In that case, that expression is a polynomial. Otherwise, it's not. Constants have no role to play in deciding if an expression is a polynomial or not. Constants do not have any role in deciding whether an algebraic expression is a polynomial or not. It's only the variable that plays a vital role in deciding if the expression is a polynomial or not. So you will only focus on the power of the variables involved. So let me write another one. So if you have xy square minus, like something like, okay, root 7, maybe you're not introduced to something like this, but root 7x square minus 5z. Okay, so our focus is only on variables, on nothing else. All right, so first of all, there are 3 terms, 1, 2, 3 terms, because terms are separated by a plus or a minus sign. So you can see a separator here, minus. So 1 first term, second term, and again a separator here, third term. 2 separators, so 3 terms will be there. Okay, now in the first term, you can see the variable x. Its power is 1. There is no power there. You don't see anything, but it's 1. If there's nothing, it's 1, whole number. Next, in the first term itself, you see another variable y. Its power is 2, whole number. Move on to the second term. In the second term, you have something like root 7. That's a constant. Ignore it. Ignore the constants. Okay. In the second term, we have another variable x. Its power 2, whole number. And in the last term, the third term, we have 5, which is a constant, which we are not concerned about. The variable in the third term is z, whose power is 1, which is a whole number. So when we inspect the powers of the variables x, y, and z involved in this algebraic expression, throughout the powers were whole numbers only. There was no deviation. The power everywhere was a whole number. It can be 0 also. 1, 2, 3, anything, but it should be a whole number. It should be a whole number. And yes, we checked in everywhere, in all the 3 terms, the variables are raised to a power which is a whole number. So this expression is a polynomial. This is an algebraic expression. It is also a polynomial. It is also a polynomial. Now consider this. Consider this. This is only one term. ABCD is only one term because there's no plus minus separator here. So only one term. ABCD is one term. Now we have in this one term, there are 4 unknowns, 4 variables. A, B, C, and D. A is raised to the power 1 whole number because all are variables. So we need to check the powers of every variable involved here. A is raised to the power 1, B is raised to the power 1, C is raised to the power 1, D also raised to the power 1. 1 is a whole number, 1 being a whole number. A, B, C, D is a polynomial, but there's only one term. But we thought poly means many, so many terms is a polynomial. No. A polynomial can have even one term. But that one term should be a non-zero term. You cannot write 0 and say, yeah, see, this is a polynomial. A polynomial can have even one non-zero term. Okay, if I write, now we'll not go into this discussion, but 5 is an algebraic expression and it is a polynomial. 5 is an algebraic expression and it's also a polynomial. So we'll do all this next year. For now, this understanding is more than sufficient. ABCD is a polynomial. So don't think many terms. If the expression has many terms, then it's a polynomial. No, that's wrong. That's not at all the definition. That we assume ourselves from the English meaning of poly. No, it's not that. So this is an algebraic expression. This is only one term, but there are 4 variables. But every variable is raised to a whole number power. The power is a whole number everywhere. So it's a polynomial. Now, if you're curious to know an example of an algebraic expression, which is not a polynomial, let me tell you. So if I have root x plus 1 by x. All right. So again, we'll see more of this next year. I'm just giving you an example. Maybe you want to know then how does an algebraic expression which is not a polynomial look like? How does an algebraic expression which is not a polynomial look like? So one of the many examples, infinitely many examples is this. So root x plus 1 by x. Root x means x to the power 1 by 2. Root x, this is called the radical form. This is called the radical form and this is called the exponential form. Okay, root x can be written as x to the power 1 by 2 plus 1 by x can be written as x to the power minus 1. 1 by x. So we will see this. Oh, we've already completed exponents here. So if you can recall, 1 by x is x to the power minus 1. Reciprocal of the base, negative of the power. Okay, 1 by x. Reciprocal is x and negative of the power. 1 by x is 1 by x to the power 1. Children, we have finished exponents here. Please recall 1 by x to the power 1 can also be written as, the rule is reciprocal of the base, negative of the power. The base is 1 by x, reciprocal of the base, x, negative of the power, 1 becomes minus 1. So, write this again. Root x plus 1 by x is equal to, is also, I'm not solving this. I'm just writing the other way of this. I'm just showing you the other way of, interpreting this expression. Root x is nothing but x to the power 1 by 2. Plus 1 by x is x to the power minus 1. Using the rules we have learned in exponents. All right. Now look at the, so 1, 2 terms. 2 terms. 1, 2 terms. All right. The separator is plus. Okay. So the variable, in the first term, the variable is x. Its power is 1 by 2, which is not a whole number. In the second term, the variable is x, which is not a whole number. It's not a whole number. Is it 0, 1, 2, 3, 4, 5, 6, 7, 8, 9? No. It's minus 1. It's an integer. It's not a whole number. Is 1 by 2 a whole number? No. What are whole numbers? Counting numbers including 0. Whole numbers are counting numbers including 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Counting numbers and 0 form the collection of whole numbers. So 1 by 2, you will not count 1 by 2, 1 by 3, 1 by 4. No, we don't count like that. So 1 by 2 is a 1 by 2 is a fraction. It's an integer. I'm sorry, it's a rational number. 1 by 2. It's not a whole number. So x is raised to the power 1 by 2, which is not a whole number. And here in the second term, the variable x is raised to the power -1, which is not a whole number. So since the variables in this expression do not have whole numbers as their powers, this expression is an algebraic expression, but not a polynomial. Do you have any question now? Yeah. Louder. You missed the chapter exponents. Okay, I'll share the recording. The exponential way of writing root x is x to the power 1 by 2. There's a 2 here. There's a 2 here. So root x is written as x to the, okay, let me tell you this. Cube root of x can be written as x to the power 1 by 3. Fourth root of x is written as x to the power 1 by 4. So square root of x, meaning there's a 2 here. We don't write a 2 there, but there is a 2. Like when we write 6, it's +6, but we don't write +6. Even if you don't write plus, we know there's a plus there. Similarly, why do we read this as square root? Square. This is square, no? This is a square, right? A square. Right, so square root, because there's a 2 here. Yeah, for the others, you have to specify. Yeah. Probably they teach only till primary level, so that is out of their understanding or their knowledge. Right? Yeah. That's right. Is that fine, children? No, because year after year I face this. This is not the first year. Every year children have this question. Yeah. Yeah. Is this fine, children? So do you now understand how to differentiate polynomials from algebraic expressions?
Yes, ma'am.
Yeah. So now see here. What is a polynomial? An algebraic expression in which the variables involved have non-negative integral powers. The meaning of non-negative integral powers meaning whole numbers. Integral meaning integers. Okay. So -3, -2, -1, 0, 1, 2, 3, 4. All right. Now, these are negative integers, right? Meaning it continues, but these are negative integers. Non-negative meaning the rest of it are non-negative. You take away the negative integers. Cover the negative. See, there are infinitely many negative integers. I'm just saying cover that part on the number line. If you cover that negative, if you cover that part of the number line which has negative numbers, what do you see? 0 and the positive integers, right? What are they called? Whole numbers. So non-negative does not mean positive. Non-negative means other than negative numbers. Non-negative meaning other than negative numbers. Number line 0, -1, -2, -3. It goes on like this. Non-negative meaning remove all the negative ones. Remove the negative one. The rest are all, these are non-negative. These are non-negative. So what is this collection called? What do you call this collection? Whole numbers. So non-negative integral meaning of integers. Integral meaning integers. Like you say floral meaning, if you say my dress has some floral design, meaning of flowers. It's made of flowers. Okay, so my shirt or my dress, my kurti has floral patterns in it. So that means it's made up of flowers. All right. So some design using flowers is floral. So of integers is integral. All right. So integral powers is called a polynomial. So this is the definition of a polynomial. An algebraic expression in which the variables involved have non-negative integral powers is called a polynomial. Now, see some examples of polynomials. Look at this one. A is the variable, power 2 whole number. B variable, power 1 whole number. In this is another one. See, I've separated the examples with the comma. This is one example. This is another example. This is another example. So there are 4 examples here. They're different. They're different. I've separated the examples with the comma. So this is an example where you have 2 terms, wherein in the first term we have the variable x with power 2 whole number, polynomial. 3 terms. All right. First term AB, power 1, power 1. Power 1, power 1. Second term CD, power 1, 1. Whole numbers, polynomial. Z raised to the power 100. See, this itself is a polynomial. Z to the power 100 is a polynomial. Because it's an algebraic expression, it's an algebraic expression because you can see, you should see a constant or a variable. Yeah, you have a variable Z there. Even a constant is an algebraic expression. Simply, I told you, simply 7 is an algebraic expression. All right. So the variable is Z, its power is a whole number, so polynomial. So if you have understood that polynomial means an expression with many terms, please unlearn that and learn this. A polynomial can have many terms, but everything that has many terms need not be a polynomial. A polynomial can have 1 term, 2 terms, 3 terms, many terms. So this is what decides a polynomial. Non-negative integral powers of the variables involved decides a polynomial. Now, what is a monomial? A monomial is a polynomial with 1 non-zero term. A monomial is a polynomial with 1 non-zero term. A binomial is a polynomial with 2 non-zero terms, because you cannot write 0 plus 0 and say this is a binomial. Or you cannot write x plus 0 and say it's a binomial. X plus 0 is not a binomial because 0 is not considered there. Okay. Okay, so a monomial is a polynomial. See, if I give this example for a monomial, okay, cube root of x, this is not a monomial. It has 1 term. That doesn't make it a monomial. It has 1 term. Only 1 term, mono, single. That's what English says. No, mono, 1 means monomial. No, this is not a monomial. Because if it's a monomial, it should be a polynomial. So is this a polynomial? There is 1 term, that's fine. If it has 1 term, it doesn't mean it's a monomial. Okay, now we have to find out if this is, or we need to understand if this is a polynomial first. So this is nothing but x to the power 1 by 3. And sorry, 1 by 3 is not a whole number. The power 1 by 3 of x is not a whole number. So cube root of x is an algebraic expression, but not a polynomial. And if it is not a polynomial, it's not a monomial. It is an algebraic expression with 1 term. It's an algebraic expression with 1 term, but that doesn't make it a monomial. For an expression to be a monomial, it should be a polynomial in the first place. It's not enough if it is an algebraic expression. For a term for a term to be a monomial, it is not sufficient if it's an algebraic expression. It should be a polynomial. First check with a polynomial. If it is a polynomial, then check. If it has only 1 term, it's a monomial. Okay. Binomial, a polynomial with 2 non-zero terms. Trinomial, a polynomial with 3 non-zero terms. So I think you can understand examples, children. You can see here, these are monomials. Binomial meaning 2 terms. 2 terms, and all these are polynomials. Here you can see 3 terms, 3 terms, 3 terms. Okay. All these are polynomials with 1 term monomial, with 2 terms binomial, with 3 terms trinomial. What is a 0 polynomial? 0 is the 0 polynomial. You cannot write examples. 0, this number 0 is called the 0 polynomial. And constant polynomial, every constant meaning every non-zero real number other than 0. Other than 0, every number is a constant polynomial. Okay, there are infinitely many collection of numbers, right? Every number is a constant polynomial other than 0. 0 is a 0 polynomial. 0 is not a constant polynomial. It's not a constant polynomial. It's a 0 is a polynomial. 0 is a polynomial, but 0 is not a constant polynomial. 0 is a zero polynomial. 0 is the zero polynomial because that's the only term. Like you say, 1 is neither a prime number nor a composite number. 1 is a unique number, right? In the same way, 0 only. The 0 is called a zero polynomial. All other numbers are constant polynomials. And this pi, because pi has a numerical value, right? It's a constant polynomial because it has a numerical value. For the sake of calculation, we use 22/7, but otherwise it's a non-terminating, non-repeating decimal, which again you will see next year. So for the sake of for computing purposes, we take pi as 22/7. Its value is not exactly 22/7, but in order to compute the value, we take it as 22/7. It's roughly, not even roughly. Okay, so again, that again is a big discussion. We'll do it later, meaning not this year at all. So these are the terms now: polynomial, monomial, binomial, trinomial, zero polynomial, and constant polynomial. Is that fine, online students?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
All right, very good. So that's about the introduction. Now, last class actually I started with my material. We'll do that a little later. This is NCRT. This will be simpler. So we'll understand from NCRT first, and then last class I started with my material. I'm not resuming that. Okay, so this is from NCRT. So we'll do this. These are simpler. We'll understand this, and then we'll switch to what I started in the last class. All right. So example, you can see here add. So we have a few expressions. We have a few expressions, 1, 2, 3. We need to add these 3 expressions. All right. Now adding, subtracting, we have 2 ways. You can arrange them vertically and add or subtract. Addition, subtraction of expressions. Adding or subtracting algebraic expressions can be done in 2 ways. One is the vertical method, the other is the horizontal method. What we did in the first class on Monday, okay, was the horizontal method. I'll introduce you to the vertical method now. All right. We have both. Sometimes it's specified in school, meaning in school you may have this specification. Find the sum using the vertical method. Find the sum using the horizontal method. So for that sake, we need to learn both the methods. All right. So here we have 3 expressions. We have 3 expressions. We need to add these expressions, find their sum. Now we'll do it in the vertical method. Okay. So this one by sight you can understand. I don't have to say anything much. So now see here, these 3 terms you can see here. And then this YZ term, I placed it below YZ. Then this 9ZX below ZX. And this minus 4Y, it doesn't have a company. Here, see, Y term is not there. So it's alone here. It's alone here. Then in the third expression, XZ. Is there any XZ? Yeah, there is XZ. So write it below that. And see, it's minus 3XZ. So write it under this. See, all these are ZX. Or both are the same. XZ can be written as ZX. Because multiplication is commutative, right? Because 4 into 3, 3 into 4, both are the same. So X into Z, Z into X, both are the same. So you can see this one, and this one below the other here. I've written this XZ as ZX, So from the third expression, this one is here, and 5X, it's here, and minus 2XY below XY. All right. Both of you can come here. All right, then you know how to simplify. Second bench. Then you know how to simplify. Right? Because we understood that when we simplify like terms, the result also will have the same literal factors. See now in 7xy, x and y are letters, no? So we call them the literal factors. See the factors of 7xy, which you have studied in grade 7. The factors of 7xy are 7. See, this can be written as 7 into x into y, where 7 is the numerical factor of 7xy and x and y are the literal factors, letters. Again, like integral is of integers, literal is of letters. Literal factors, meaning of letters. So in 7xy, x and y are the literal factors, the letters, or simply literals. And 7 is the numerical factor. Correct? Okay. So when you add or subtract, the literal factors come down as they are. When you add or subtract, you can add or subtract only like terms. That means they must have, the terms must have exactly the same literal factors. You can add or subtract terms that have exactly the same literal factors. If one term has xz, it can be simplified with another term which has xz, exactly xz. The numerical coefficient can be anything, but the literal factors must be exactly xz, nothing less, nothing more. If xz is x square, z square, no, they don't become like terms. Xz, xz only. You're very strict there. Xz, xz. X square, y square, x square, y square. X cube by x cube by. The literal factors must exactly be the same. Only such terms are called like terms. So like terms are terms that have the same literal factors, and only these terms can be simplified by addition or subtraction. For multiplication division, we have no rules. Anybody, anything, you have 2 terms, you can multiply them. You have 2 terms, you can divide them. But if you have to add or subtract, you need to check if the two terms or whatever, how many ever terms you have the same literal factors. Only then you can add or subtract them. So see it xy, same thing, no? So that xy will come down as it is. Xy. Simplify only the numerical coefficients. 7 minus 2, 5xy. See the simplifying part only for this sum I'll explain. The others I will not explain. So if you have a doubt, ask me now. Then yz, see yz. Okay, we are very strict. So yz only. Yeah, they are yz. So they have exactly the same literal factors. So you can proceed to simplify them. Plus 5 plus 4 plus 5 plus 4 plus 9 yz. Zx. I said xz, zx, both are the same. Okay, so xz or zx, whatever, zx. So zx. The answer will also be one among them, like term. So minus 3 plus 9 minus 3. Simplify this. So minus 3 is minus 6 and plus 9. So 3 zx. And see, these don't have, similar terms. So they just come down as they are. So plus 5x minus 4. So this is how the vertical method of finding the sum of 2 or more expressions work. You need to place the like terms one below the other. And this is exactly what you have to do. Online students, any questions?
No, ma'am.
No. Okay. All right. Now subtract. Vertical method. We are not doing the horizontal method, the vertical method. Subtract. Subtract the first expression from the second one. So we've been learning this, since I think second or third. Whenever we subtract, the expression after from should be written first. Whatever is after from should come first. And then the one before from. The one after from will be written first or will form the top row. And the one which is before from will form the bottom row. in the vertical method. Vertical method, when you have to place the expressions one below the other, when you have to subtract one from the other, the expression which is after from will form the first row, and the expression that is before from will form the bottom row. And when it is subtraction, you can do only 2 at a time. Like addition, you cannot place 5, 6 expressions and add everything at the same time. Addition, you can do that. If you have 6 expressions to be added, you can simply place them one below the other, making sure that the like terms are placed correctly, and you can add all 6 in one shot, one go, you can do it. But subtraction, you cannot do that. Subtraction, only 2 at a time. Only 2 at a time. After from first row, before from second row, that's all. If there's another expression, wait, we have to finish this and only then use that. That's it. Now, when we have to subtract, in the bottom row, change the signs. That's what we always do. I'll tell you. That's what we always do. Like when you multiply, online students, are we all attentive? Raise your hand. Aishwarya, Anantika, Harsha, and Sai Smriti. Use the raise hand option. Raise your hand. Okay. Anantika. Good. Sai Smriti, Aishwarya, and Harsha. Anantika, you there? Yeah. All right. Thank you, Chidu. So in subtraction, yeah, I was telling you 1 second here. I was telling you something else here. Now, when we multiply, 45 into 23, say, what do we do? 15, 1 carried over. My multiplication is very bad, actually. So just tell me if I'm right. Then we put a 0 or multiplication here, whatever, 0 or whatever. And then 2 5s are 10, 1 carried over, 9. Okay, then what do you do? You're adding, no? 5, 3, you're adding, right? 5, 3, and 10. Addition you did. Addition you did. But what do you do in division? What do you do in division? 135 divided by, say, 3. 3 4s are 12. Then what are you doing? What is the next step? You subtract, but it is plus. It's plus. Yeah, but actually it's plus. It looks like plus here and plus here. No, why are we subtracting? That's because we don't show, but actually we change the signs. We change the sign. In the bottom row, we have 12 and we change the sign. We don't show that. In the bottom row, we have 12 and actually it's plus 12. We make it minus 12 while dividing. And 13 minus 12 is 1. Now 5 comes down. 3 5s are 15. And 15 and 15 is 30. But we've been writing 0 always. That's because in the bottom row, we have 15. We change the sign. Plus becomes minus. 15 minus 15 is 0. So remember that we've always been doing this. Whenever so subtraction means you'll have to change the signs. When you have to subtract, you're changing the sign. In the bottom row, you're changing the sign. Do the same thing here. Do the same thing here. This is the expression after from, this one. This is this expression before from. And in the bottom row, change the signs. Plus 5x square becomes minus 5x square. Minus 4y square becomes plus 4y square. Plus becomes minus, minus becomes plus. Take the opposite signs. Actually, you're supposed to write it here. See, you're supposed to do it here itself. Minus and put a plus like this. Take a minus like this and a plus like this. Or maybe you can write it below. You can even write it below like minus, plus. This is minus because it's actually plus. And plus becomes minus and this becomes plus. But I cannot do that while typing. While typing, I cannot put it there. So I show it below here. You can also show it here. This is fine. But normally we show it below the sign here itself. Below or above the sign. So, all right. I don't think this is a very difficult instruction for you. All right, yeah. Yeah. So change the signs. Every term in the bottom row, change the sign, meaning put the opposite sign. Plus becomes minus, minus becomes plus. Now do the same thing. Now forget the original sign. Now this is 7x squared minus 5x squared. Forget the original sign. So x square, x square, x square. Simplify the numerical coefficient. 7 minus 5 is 2. So 2x squared. Now this one as it is, because it does not have a partner. There is no term that looks like x, this term. So that comes down as it is. And here y square. Okay. Now forget this sign. This is the new sign. So 8 plus 4, 12 plus 12 and y square as it is. Now this one also. No friend. So it comes down alone. Minus 3y, minus 6y children. See, forget the original sign. Take the new sign. Minus 3y, minus 6y. Y. Minus 3, minus 6, minus 9. Minus 9. And remember, this minus 3 is in the bottom row and it's now plus 3. So it comes on as plus 3 children. In the bottom row, forget the original signs, take the new signs. So this one is minus 3, but we change the sign. No, this is not there. It's plus, so plus 3. So you people, please place the sign here itself. You do it like this. Do it like this so that it's clear. But everywhere in my presentation, it will be in the bottom row like this. But now you understand, so I will not mention this again. Spend your time, waste your time. Is this clear, children? Now
Yes,
in
ma'am.
top, yeah, very good. In the top row, we have minus 4xy. Now don't get confused. Minus 4xy, how it's coming down as it is. We are not changing the sign. That's in the top row. Top row, don't change the signs. Only the second row. Only second row, you must change the signs. And the literal factors will come down as they are. Y square. XY. Only the numerical coefficients should be simplified. That is in the horizontal method, not here. That's in the horizontal method, not here. That the presentation is only this. That's the horizontal method. All right. So this is about subtraction. Addition, you can place even 10 expressions one below the other. No changing signs anywhere. Simply do it like that. And when you add or subtract, only the numbers you're going to calculate. The literal factors will come down as it is. X square. 10 times you have x square will come down. If you have to add 2x square minus 5x square minus 17x square plus 90x square minus 105x square, answer is x square only. Only the numbers you will simplify. So in some answer you'll get x square. Don't write that as x to the power 12 or 20. Don't add the powers in x square and not like that. Okay. So this is about subtraction. So these are easy, children. I'm not going to spend time on all this. Terms and coefficients. You can understand this. If you don't see any, see when we say coefficient here, no, they're talking about the numerical. If nothing is specified, we are talking only about the numerical coefficient. If it is simply coefficient, what coefficient? Only the numerical coefficient. Coefficient with no instruction is only numerical coefficient. All right. So now what is the, this is a constant. You can write the constants also for numerical coefficients. All right. So see here, 3, coefficient 3. And for this one, what's the number? Minus 1. So that's what minus 1. Or for this one, plus 1. So or simply 1. And for this one, it's minus 1. Minus 1. The numerical coefficients. You can write the constant also. All numbers you see there, you can write. This is an expression. Okay, so this is a question where you have an expression. This is a question where you have an algebraic expression. From this one, you will have to write the terms. What are the terms of this expression and what are the coefficients you see there? So what are the terms you see there? Terms are 3. You see 3. You see minus PQ. You see plus QR. You see minus RP. All right. They are the terms. And what are the numbers you see? You see 3. And here you see minus 1. And here you see plus 1. And here you see minus 1. Okay, so this you can help yourself. Classifying as this is classifying as monomial, binomial. Okay. So here you have some expressions. You have some expressions here. You have some expressions here. All these expressions are polynomials. All these expressions given here are polynomials. That's given in the question. That's given in the question. Classify the following polynomials as monomials, binomials, trinomials. I think now your doubt will be, this is the heading. This is the heading. classify the following polynomials as monomials, binomials, trinomials. Which polynomials do not fit into any of these three categories? Because that means if it has more than 3 terms, then it will not fit into any of these categories, right? You are giving only 3 categories. See, there are cats, dogs, donkeys, buffaloes, horses, many animals, but you are giving only 3 categories: cats, dogs, and maybe some cows. What are the other animals? So they don't fit into these 3 categories. So like that here, this one has 2 terms, it's a binomial. This one has only 1 term, it's a monomial. Board. This one's here, 2 terms, binomial, 1 term, monomial. 4 terms does not fit, because this is a polynomial. This is a polynomial because see the powers of the variable x everywhere: power 1, power 2, power 3, power 4, everywhere whole numbers. So it is a polynomial. It's a polynomial, but you have to say if it's a monomial. No. Is it a binomial? No. Is it trinomial? No. It has 4 terms. So it's a polynomial with 4 terms. It's a polynomial with 4 terms. So you will see the special names for these next year. So for you now, it's a polynomial with more than 3 terms, or it's a polynomial with 4 terms. What is this one? It's a polynomial with 4 terms. Or you can say it's a polynomial with 15 terms, a polynomial with 10 terms. If it has 1 term, monomial, 2 terms, binomial, 3 terms, trinomial. Not everything. If it's a polynomial, then if it has 1 term, monomial, 2 terms, binomial, 3 terms, trinomial. It's a polynomial, but it has more than 3 terms. It is a polynomial with, say, 4 terms or 5 terms. That's all. So what is this? It's a polynomial with 4 terms. This is a trinomial. This one is a binomial. This one is a trinomial. This one is a trinomial. This one is a binomial. This one is a polynomial with 4 terms. It's a polynomial. Now, why is it how can you say it's a polynomial? Okay, the heading is given following polynomials, but even we know, now we know how to identify polynomials. So you want to check it. So first term, power 1, variables. A is a variable, power 1. B is a variable, power 1, whole number. B, C, 1, 1, 1. Everywhere the variables are raised to the power 1, which is a whole number. So it's a polynomial. But this polynomial has 4 terms. So it doesn't fit into any of these 3 categories. It's a polynomial with 4 terms. Monomial, binomial, binomial. None, children? All right. So add the following. You can help yourself. Correct? Am I right, children?
Yes, ma'am.
Yeah. So just place the terms. See, you can see that the placing is very important. If it has, if you have like, if you find like terms, place them one below the other. Like terms, place them one below the other. So now see here, the C, when you're writing the C, you know, C minus A plus AC. There is C here. Below C, you should write C. But what is the C? It's plus C. No, so put a sign. See, now the first term here, there's no sign, so you know it is a plus. You know it's a plus. But when you're writing a term in the middle, don't just write C, plus C. So you can see I placed A below, one below the other, B, AB is alone, C, BC is alone, AC is alone. All right. So here we have P square, Q square, PQ, and numbers or constants. So here, okay, let me just push this away. By mistake, I've just pushed it here. Actually, you should not write it under this, you know. I was editing it today. In a hurry, I've just pushed it here. Sorry. I'll correct this one. It should be like this. You shouldn't place it here. You should not place it here. It's not here. It's away. So L square, L square, L square, L square, L square, M square, M square, N square, N square. Then this one as it is. See, this first expression, no, is here. This is second expression. That's what is here. This is a third expression. That's what is here. And this is the fourth expression, which should not be here, children. It should be away here. Okay, because L square, LM, no. I was editing it today, so by mistake I pushed it here. I was just spacing it, so push it. All right, so I told you this will not come here, it will be here. So 2 LM plus 2 MN plus 2 NN. What happened? Okay. Yeah. And then since in the result, you can see 2 common everywhere, right? So you can also write it as take out 2 common and write in the bracket. Take out 2 common. You should understand that. Take out 2. See, there every term has a 2. Every term has a 2 there. Every term has a 2. So you can write the 2 outside. And L square. See, I've cancelled the 2. So what is remaining? L square, M square, N square, LM, MN, NL. Can you see that here? Yeah. Subtract. Subtract. So I have nothing to say. You know it. Sorry. In your school, huh? Last year. We're not doing this, children. You already understood how to subtract one expression from another or one polynomial from another. Correct? What is after from? Write it in the top row. What is before from in the bottom row? And in the bottom row, every term opposite sign. And put that in the bracket. Forget the original signs. Take only the new signs and simplify. And place the like terms one below the other. While adding or subtracting, that is important. Place the like terms one below the other. If it was xy only will come the answer. Only the numbers you should calculate. The numerical coefficients. So that's about exercise 9.1 from NCERT. Over to exercise 9.2. Ready? Online students? Are we good to go to the next one? Yeah.
Yes, ma'am.
All right. So this is complete the table for area of rectangle with given length and breadth. All right. So rectangle, area, L into B. Rectangle, area of a rectangle, L into B. Now for multiplication, you don't have to worry if they're like terms or unlike terms. You have 2 terms, multiply them. You have 2 terms, divide them. You can perform multiplication and division with both like as well as unlike terms. Only addition and subtraction can be performed on like. Addition and subtraction can be performed only on like terms. Now supposing we have x plus y plus z in the top row and a plus b plus c in the bottom row, and we have to add this. When you add, you will get x plus y plus z plus a plus b plus c. That's all. Or a plus b plus c plus x plus y plus z. They can't be simplified. Why? Because they're not like terms. For A, there's no other A term, there's no other B term, there's no other C term, there's no other X term, Y term, Z term. Nobody has a company. Nobody has another person which looks like it. So they cannot be simplified. They come down as they are. A plus B plus C plus X plus Y plus Z. Okay, now here it is multiplication. Anybody? 2 terms? Chalo, let's multiply them. Okay. So now area of a rectangle is L into B. So 3x into 5y, correct? 3 into 5. Multiply everything. Multiply the numbers. Multiply the numbers with the numbers. The little factors with the little factors. For multiplication, you must multiply the numbers with the numbers. The little factors with the little factors. So what do I mean by that? One second. Let me tell you something else. Supposing we have 4x square into minus 3 x, y. All right, multiply the numbers. 4 into -3, -12. Then multiplying numbers. Now multiply x squared with x. X square and x, they are not like terms. They are different. X square, x, they are different, but you can multiply them. What is x square into x? Exponents. When bases are same and it's multiplication, add the powers. 2 plus 1, x cubed. So x square into x is x cubed. And y as it is. We multiply everything you see. I repeat this. If we have to multiply 4x square and -3xy, we see that they are not like terms. 4x square and -3xy are not like terms, but we can multiply them. Multiplication is not sensitive. We can multiply them. Now, how do we multiply? Multiply the numbers. -12. And multiply the literal factors, the letters. X square into x. Now, how to multiply x square and x? Exponents. When bases are same and it's multiplication, we add the powers. So write x and add the powers. 2 plus 1. So x to the power 3. Don't show these steps. You can directly write x to the power 3. Because x square into x, bases same, multiplication, add the powers. X to the power 2 plus 1, 3. Add the powers. Don't multiply the powers. Add the powers. Then y. So the product is -12 x cubed y. Now Shivam will tell us what is x square y cubed into 5x to the power 4, y to the power 7. Yes, quickly. What's the product? Write the number first. Write the numerical part first.
Ma'am, should I say the answer?
Yeah, I'll just come to you, Aishwarya. I've asked somebody here in the class. Yeah, thanks, Aishwarya. Just a minute. Yes, Shivam. So 5, there's 1 here. So 1 into 5 is 5. All right. I know you know it, but you're hesitant to say. 1 into 5 is 5. Let's do it together. What is x square into x to the power 4? What is x square into x to the power 4? X to the power 6, because 2 plus 4 is 6. Yeah, x to the power 6. And then what is y cubed into y to the power 7? Y to the power 10. Y into y to the power 7. No, see, the thing is we need to understand the rule correctly. You process it slowly. You do the addition, subtraction slowly. That's okay. That speed you can improve, but understand the fact correctly. If you feel you're not able to process the answer quickly, that's okay. With practice, you can process it faster. But get the fact correctly. How to multiply, that you should understand clearly. There, if you have a problem, you should ask. But if you feel, no, I know, but I'm not able to do it fast, that's fine. That's fine, meaning with practice, you can overcome that yourself without anybody's help. But the fact, to understand the fact correctly, yes, you need a teacher to make you understand the fact correctly, and that's my job. Is a fact understood? Is a procedure understood? Yeah. So it's like 1 into 5, 5. X square into x to the power 4, 2 plus 4, 6, x to the power 6. Y cubed into y to the power 7, 3 plus 7, 10. Right. And when you don't put any sign in the middle, it's multiplication. If you don't put any sign, it's multiplication. When we write ABC, what is this ABC? A into B into C. ABC is not A plus B plus C. ABC is A into B into C. Yeah, I'm showing you the answer. If you have any doubt, ask me. You're not working anything in today's class, children. If you have a doubt, ask me. The question, what is the question? This is the answer. What's the question? You'll have to fill in the blanks. You'll have to fill in the blanks. Area column, the first one is done for you. The others you'll have to complete. All right. So that is what you should see here. So I'll just do the last one for you. So 2 into 3 is 6. L square into L. It's not 1, children. It's not 31. It's 3L. 3L. So L square into L. L to the power 2 plus 1, 3. L cubed. M into M square. 1 plus 2, 3. There's 1 here. There's 1 here. 1 plus 2, 3. Good, all of you? Okay.
Yes, ma'am.
Very good. Yeah. Now this is about volume, children. I'll just do the first one and then show you the slide, the answer slide. So volume, a rectangular box meaning a cuboid. Okay. Rectangular box meaning cuboid. And the formula to find the volume of a cuboid is L into B into H, cubic units. L into B into H, cubic units. Area of a rectangle, L into B, square units. Volume of a rectangular box meaning a cuboid. Okay, is L into B into H. Okay, so L is 2AX into B, 3BY into L into B into H, 5CZ. Now, if we don't understand what this is, you can work this further like this. This means 2 into A into X into 3 into B into Y into 5 into C into Z. This is the meaning. See, once you get comfortable with this, you don't have to show these steps. Or by your, see, like on your own, you will neglect a few steps, which is fine. So now as a beginner, as we are new to this, you know, you'll be initially working these steps. Once, you know, like you come to the end of this chapter, you will not write all this. You'll write the direct, meaning the final answer, the product directly. So this is the meaning. This is the meaning. Now further, you can group it like this: 2 into 3 into 5 into, you can write the ABCs first, A into B into C into X into Y into Z. You can just arrange just to understand. So now the product is 2 3 the 6, 6 5 the 30. ABC XYZ. 30 ABC XYZ. So you can give these steps if you want. This is L into B into H. L is 2 into A into X. B is 3 into B into Y. And this is H is 5 into C into Z. For further understanding, you can just rearrange 2 into 3 into 5. Then write the terms in the order. Meaning like they appear in the English alphabet. So write ABC first and then XYZ. To 30 ABC XYZ. But it's not wrong if you write 30 A, X, B, Y, Z, C, any order. You write this in any order, you're right. Okay, but this really can't, this if you have to check if you're right, you yourself can't make out if you're right. So you write it in this order so that you know you've not missed anything. A, B, C, X, Y, Z. So it's easy to check. A, B, C, X, Y, Z. I've written everything. That's how you present it. Yeah, have a look. These two steps can be avoided if you feel, you can understand directly. You can avoid these two steps. You can directly write 2 into 3, 6, 6, 5 are 30, 30. AX, BY, CZ is ABC, XYZ. Directly you can write it. So what I have shown in these two steps is first I've written 2 into A into X, 3 into B into Y, 5 into C into Z, and then I've rearranged. In the next step, I've rearranged the numbers, then in the order, A, B, C, X, Y, Z in the order. Is somebody talking to me? So here also see L into B into H. So first, next step, what I've done is I've written this as 2 into Q, 4 into Q squared, 8 into Q cubed. Then in the next step, I'm gathering the numbers first. Because see, 5Z, we don't write it as Z5. Numerical coefficient comes first and then followed by the letters. Phi z cannot be written as z phi. No. That's not an accepted way of writing. See, you may argue that multiplication is commutative. Multiplication is commutative. When you say that 4 into 3 is 3 into 4, then 5 into z is also z into 5. The meaning is fine, but it's not an accepted way of writing. It's not an accepted way of writing. Correct? So for certain things, we have certain conventions. You know, we do certain things in a specific way. So it's conventionally accepted. That's it. Okay, so we always write the numerical part first, followed by the letters. So you cannot write q to the power 6, 64 like this. It is 64 q to the power 6. So again, children, I don't want you to get confused here. For I said you may avoid these 2 steps. But as a beginner, if you think you're just learning, it's very new to you, please show these 2 steps. When you practice like this, it becomes very clear to you. And eventually you will miss to write those 2 steps, not consciously. Without knowing, you will miss those steps. So what have I written here? 2q is 2 into q, 4 into q square, 8 into q cube. Then I've gathered 2, 4, 8. I've gathered the numbers and then gathered q square and q cube. And here, how do you multiply this? We need to add the powers. 1 plus 2, 3, 3 plus 3, 6. Q to the power 6.
Ma'am, may I be excused for a minute?
Yeah. Okay. Yeah, children. So I'll just show you, I'll just tell you this first one. Multiply. See, the heading is find the product of the following pairs of monomials. Pairs of monomials. See, following pairs of monomials. Monomials meaning single term. Pair meaning there are 2 monomials. Following pairs of monomials. Monomial is a single term. Pair of monomial meaning 2 monomials. So you can see 4 is a monomial. See, I told you, no, 4 is a monomial. 4 is a polynomial. It's a constant polynomial. 4 is a constant polynomial. So 4 is a monomial. 7p is a monomial. Multiply them. Find the product. So minus 4p is a monomial. 7p is a monomial. Find the product. This one is a monomial. This one is a monomial. Single term. Find the product. So that's what is the heading. Let's see the third one. So we need to multiply. So how do you multiply this? It's minus 4 into p into 7. See, minus 4 into p into 7 into p into q. The next step, I've gathered the numbers. Minus 4 and 7 I've gathered. Minus 4 and 7. And then p, p and q. P, p and q. Now this is minus 28. P into p. What is p into p? P to the power 1 into p to the power 1. Base are same, it's multiplication. We add the powers. 1 plus 1. So p to the power 2. So p squared q. That's what it is everywhere. Again, area. Okay. Find the areas. Find the areas of the rectangles with the following pairs of monomials as their lengths and breadths respectively. This one is a monomial, this one is a monomial. This one represents the length, this one represents the breadth of the rectangle. See, that's what is heading. Find the areas of the rectangles with the following pairs of monomials as their lengths and breadths. So this is a pair of monomials. Pair of monomials. Pair of monomials. Meaning 2 monomials. Wherein the first one is the length, the second one is the breadth. Find the area. So L into B is area. L into B is area. So let's see the third one. Third one, 20x square into 5y square. So what do you understand by this? It's 20 into x square into 5 into y square. Then gather the numbers, 20 into 5. Then gather the letters, x square and y square. So 20 into 5 is 100. X square into y square bases are different, so you cannot multiply them. Like x square and x cube, x square and x cube, they are not like terms, but you can multiply them. X square and x cube, they're not like terms. This is x square, that's x cube. They're not like terms, but you can multiply them because they have the same base x. So you can add the powers 2 plus 3, 5 and write x to the power 5. But this one is x square, y square. You cannot add the powers there because bases are different. X square into y square. You cannot say, okay, 2 plus 2, 4. No. Which base will you write? Will you write x or y? Bases must be the same. So they're different. So this one comes as it is. 100 x square, y square. Remove the multiplication signs. Don't write 100. Okay, it's 100 into x square into y square. You can just remove the multiplication sign. So it's 100 x square, y square. So now you can, you know how to complete this table. You'll have to multiply. So you multiply this and this, write the product here, multiply this with this, write it here, this with this one with this one with this one, write the product. Maybe end of the class, I'll give you this task. All right. Multiplication. So again, volume, children. Obtain the volume of the rectangular boxes. LBH is given. Fine. Should we discuss this? And if Shivam says, I'll say okay. Shivam, what's the formula to find the volume of a rectangular box? L into B into H. Very good. So can you see there are three monomials, no? 5a is a monomial, 3a square is a monomial, 7a to the power 4 is a monomial. 5a is the length, 5a represents length, 3a square represents the breadth, and 7a to the power 4 represents the height. So you need to multiply to find the volume. It's just product. Obtain the product. So multiplying. Now I'll just tell you the difference between minus a square and minus a the whole square. There is a difference. There is a difference between minus a square and minus a the whole square. Minus a square is minus a square, but minus a the whole square is minus a into minus a, which is plus a square. Because the power 2 is only for a, it's not for the minus sign. If you want to indicate the power for the minus also, then you should write it in a bracket. You must write the base in a bracket. If you want to indicate that the power 2 is for the minus also in the base, then you will have to enclose the base in a bracket. So see, if you write minus 6 like this to the power 3. So this power 3 is only for 6. It's not for the minus sign. So minus 6 cubed is not minus 6 into minus 6 into minus 6. No, it's not. It's not that. You know what it is? It is minus 6 cubed is minus 6 into 6 into 6. Minus 6 cubed is minus 6 into 6 into 6. So 6 into 6 into 6 is 216 and minus 216. Getting the same answer is different from getting the same answer in some way is different from getting the correct answer in some way is different from getting the correct answer in the correct way. Yeah. Okay. So minus 2 to the power 4 is minus 2 into 2 into 2 into 2. Which is minus 16. On the contrary, if you have minus 2 in brackets raised to the power 4, the power 4 is for the entire minus 2. It's for the minus and the 2. That's why bracket. That means it is minus 2 into minus 2 into minus 2 into minus 2. Minus 2 is multiplied with itself 4 times, which is positive 16. Minus into minus plus, minus into minus plus. Positive 16. Yeah, online students, are you all there? Just say yes.
ma'am.
Yes, ma'am.
Yes, ma'am.
No, yeah. Now acknowledge. Are you all there? Sai Smriti?
Yes, ma'am.
Yes, ma'am.
Aishwarya, very good. Harsha, very good. Okay. All right, children. So that was about understanding the, understanding the difference between this and this. They are different. They are different. Here the power 4 is only for 2. So minus 2 to the power 4 is 16. This one is minus 2 4 times multiplied with itself 4 times, which is plus 16. All right. Okay, so why did I mention that? In the second one, you see, you need to find this product. So minus a squared. So plus into minus, minus into plus, minus. A into minus a square into a cube. We need to find the product. Okay. So plus into minus, minus into plus. See, there's no sign. That means plus, no. Okay, so it's minus. The product is negative. Now a square into a, sorry, a into a square into a cube. A into a square into a cube. Bases are same. Bases are same. It's multiplication. So add the powers. 1 plus 2 plus 3. 6. So a to the power 6. And it's minus a to the power 6. Because plus into minus, minus into plus, minus. A to the power 6. That's what is here, children. So this is the next exercise, exercise 9.3 NCRT. So simplify the expressions and evaluate them as directed. All right, so some instructions are given as directed, meaning follow the directions. Follow the directions given. In English, we have the setting, right? Do as directed. Do as directed. So for every statement in the bracket, you will have change the gender or whatever. What do you have such questions now? I don't know. I don't know. So yeah. So yes. So do as directed. So there'll be statements, and in the bracket for every statement, we have different instructions in the bracket. So do as directed. So when we say true or false, that means all the 10 statements under that you should only say true or false. But sometimes when the heading is do as directed and you have 10 statements below that, each of the statements will have a different instruction. So that's when you say do as directed. Okay. So simplify the expressions and evaluate them as directed. First, see the instructions given there. Simplify the expressions. So you simplify the expressions and then evaluate. So don't do the evaluation first. What we will do, meaning if I was a student also, maybe I would do this. Okay, so because this number is there, no, x is 1. So immediately 1 minus 3 plus 2. Correct? We should not do this. Simplify the expressions and then evaluate. All right, so that's what it is. There are two things we'll have to do. First, simplify and then evaluate. Don't evaluate in the first place. Don't find the value like this. Don't do this. Don't put 1 everywhere. 1 might like this. Don't do this. This is wrong. Okay. Are we ready? So simplify. So x Now this is multiplication. When we have x and in bracket x minus 3, it means there's nothing between them, right? It's multiplication. It means it's x into x minus 3. X into x minus 3. So now how do you multiply this? Multiply x with x. So you get x squared, x into x. Now you should have got used to it. X into x. Bases are same and it's multiplication. Add the powers, x squared. Okay, so x into x is x squared. Then it's actually plus x, no? See, you should, okay, fine. Let me tell you like this. When you're multiplying two terms, this is the order. First, multiply their signs. Then multiply the numerical coefficients. And then the literal coefficients. There are 3 steps in multiplying. When you're multiplying two terms, the terms are made up of 3 things. The terms may have a sign, plus minus, may have numerical coefficients, and the literal coefficients. These are the 3 things they can have. They can be of any combination. Any combination, but the 3 parts are there'll be a sign, then a numerical coefficient, number I'll write, and then letters. Every term can have these parts, sign, number, and letters. So the order is first multiply the signs, write it, then multiply the numbers, and then multiply the letters. No, in the order, that's all. In the order, what comes first? First you see the signs, multiply them. Then the numbers, multiply them. Then the letters, multiply them. Yeah. All right. So we're going to simplify now. X into x. So what is the sign? It's x into x means plus 6. And see, the sign is here. There's no sign. For a term, the sign is just before it, not after it. It's before the term. What is the sign for x? It's before it. No, before it, I don't see anything. That means there's a plus. And for this x, what is the sign? It's here. No, I don't see anything. There's a plus. That's why you don't see it. There is a plus there. Okay. So multiply the signs first. Multiply the signs first. Where are the signs? Now these are the 2 terms we'll have to multiply. The sign is here and here. So plus into plus, plus. You may or may not write it. Then numbers you don't see. Actually, there is 1 and 1. But you don't have to multiply 1 into 1 and write 1. You don't have to do that. So these 2 we just ignore. That's all. It's not that we are not using that rule. We are using the rule. Plus into plus is plus. Don't write. 1 into 1 is 1. Don't write. Then what are you writing? X into x is x squared. That you have to write. Okay. And now multiply. So x into x is x squared. Now you have to multiply x and minus 3. X and minus 3. How do you multiply x and minus 3? Multiply the signs. Plus into minus, minus. Then the numbers. There is 1 here. 1 into 3, 3. And the letter x. Multiply the signs. Term, term. Before that, sign, sign. Multiply the signs, write it. Multiply the numbers, write the result. And then multiply the letters and write the result. So x squared minus 3x. That plus 2 will come as it is. Only the contents in the bracket should be multiplied with x outside. Not this plus 2. This plus 2 is outside the bracket. That will come as it is. Now we have simplified. This is the simplification. We are done. We have done. We're done with the simplification. Now when x is equal to 1, we have 1 squared minus 3 into 1 plus 2, which is 1 minus 3 plus 2, because 3 into 1 is 3. And 1 minus 3 is minus 2 plus 2, 0. No, now you were not actually focusing. Simply you're nodding your head. That's the first one should. All right. So how do we simplify? X into x squared, x into minus 3x, plus 2 is not inside the bracket, it's outside the bracket. So it's not under the influence of this x. It's not inside the bracket. So then plus 2 will come out as it is. Now we have simplified. This is the simplification. Now for x is equal to 1, this one will become, wherever there is x, use 1 and work it. So I'll be talking only about the simplifying part, children. This substituting and finding the answer, this one you can do. Now, look at this one. This expression has to be simplified. I'll do it here. Okay, so we have 3y into 2y minus 7 minus 3 into y minus 4 minus 63. All right. So now 3y into 2y. 3 to the 6, y into y square. Settle down, settle down. No, you want the table closer to you, right? Take it closer to you. Take it still closer. You fold your legs, you feel comfortable. How do you want to sit? He's not allowing you to pull it, is it? He's put his hand tightly on the table. You're using all your strength. He's also using all his strength. You have a friend. He speaks the same language you speak. You can talk to him. You're also quiet. He's also, no, you're not quiet actually. You're quiet because you're second class. Otherwise, you're not quiet. He's very quiet. Please be friendly, meaning make friends with him. Make him talk. That's the difficult. That's the, like teaching math is easier than making Shivam talk in the class. He's still very shy and he keeps to himself. Okay. Yeah. So that is your task. Now, children, so 3y into 2y, 6y squared. Now 3y into minus 7. 3y into minus 7. So what is 3y into minus 7? 3 into minus 7, that is plus 3 it is. Plus into minus, minus 3 into 7, 21y. Minus 21y. Now we'll have to multiply minus 3 and y. Minus 3 and y. Minus 3 into y is minus 3y. Minus 3y. Now we'll have to multiply minus 3 and minus 4. Minus 3, minus 4, minus into minus plus 3 for the 12. And this minus 63 is outside the bracket. That will come as it is. So the process of multiplication goes like this. So these are the terms inside the bracket. You should multiply both the terms with 3y outside. 3y into 2y, 3y into minus 7. When you do this, the terms are outside the bracket now. The terms are free from the bracket. They break open. They break open the bracket. They're now free. Once you multiply them with 3y, no more brackets. They're free. Then multiply minus 3 with y and minus 3 with minus 4. Again, when you do that, brackets are gone. And minus 63 was already free. Put it outside as it is. Now, further simplification must be then done if there are like terms. Yeah, there are like terms, no? 6y squared minus 21y minus 3y. Y. Minus 21 minus 3 minus 24. Plus 12 minus 63. So minus 51. So we have simplified. Now we have simplified because we had like terms, so we had to do one more step. Now when y is minus 2, y is minus 2. So 6 into minus 2 the whole square, minus 24 into minus 2, minus 51. So here be careful. 6 into what is minus 2 the whole square? Plus 4. Minus 2 into minus 2 is plus 4. Okay, then minus into minus plus 48, minus 51. So it's 24 plus 48 minus 51, and then you know the answer. Yeah. Now, Sai Smriti.
Yes, ma'am.
Yeah, answer this. How do you simplify this?
1 minute, ma'am.
Yeah, no. Don't do it in your book. Tell me now.
3y square x.
Order. 3 x y square. Write x first. Then
Yes, ma'am.
Yeah,
3xy square minus 21y cube
Okay.
minus 24y power 6.
Correct. All right. Now this is for Shivam. Thank you, Saraswati. Very good.
Yes, ma'am.
Yes, Shivam. What's the answer? Loud. First thing is loud. இது multiply பண்ணும். First numbers multiply பண்ணுங்க. என்ன number தெரியுது? 4 and minus 7. Multiply. What is 4 into minus 7? Minus 28. Plus into minus minus. Plus into minus is minus 28. Then what is x cubed into x? X to the power 4. And then y to the power 5. There is no y here. So write it as it is. Next term. I can't hear you. Plus, multiply the numbers. Eight. Multiply x cubed and x. X cubed into x. X power 4. Multiply y to the power 5 and y. Last term. Multiply this one with minus 9. What do you get? First multiply the signs. Minus 36. அப்புறம் இங்க ஒண்ணும் x y ஒண்ணுமே இல்ல. அப்ப அது அப்படியே வந்துரும் அவ்வளவுதான். அங்க என்ன இருக்கு? X cubed y to the power 5 அப்படியே போட்டுறணும். All right? Okay. Okay. So that's what it is. So the simple rule to multiply two terms is this one, children. The simple rule is if you have to multiply this one and this one, multiply the signs. Plus into minus. Multiply the numbers. Multiply the letters. X square into x cube, x to the power 5, and y into y cube is y to the power 4. That's all. Multiply the signs, multiply the numbers, multiply the letters. And when you're multiplying the letters, you use a law of exponents. When bases are same and it's multiplication, we add the powers. Add the powers and write it. That's it. So here you have questions. In example 6, you see you have to add two expressions. But before you can actually add them, you need to simplify them. See here, you cannot place this expression and this expression one below the other. This itself has to be simplified. Yes or no? Horizontal, vertical, however, horizontal. Now, what I'm saying is this one has to be simplified. See, can you do this one? Can you write it like this and below that 6m square minus 13m? No, this one has to be simplified. So in such questions, you understand that you don't have to do the vertical method. understand in such, you can do the vertical method when the terms are like independent and you can place them one below the other according to the like terms. Otherwise, it's not the vertical method, it's the horizontal method. You can do the vertical method or the horizontal method always. But when you have questions like this, you should do only the horizontal method. Like when you have to simplify 5m into 3 minus m, this has to be simplified. You cannot write it in the first row, second row and add. So this one you should do it in the horizontal method. What is that horizontal method? 5m into 3 minus m plus, why plus? Because add plus 6m square minus 13m. This is the question. Now this is equal to 15m minus 5m square plus 6m square minus 13m. So this is, now you can, if you want, you can write like this, minus 13m. This will be too much, but I'm just saying if you want to rearrange, now multiplication is over, you're adding. So like terms. Like terms. When you're adding or subtracting, the literal factors will come down as they are. Only the numbers you should be simplifying. 15 minus 13 is 2, 2m. 5 plus 6 is 11, 11m square. You will not write m to the power 4. You're not multiplying, you're adding or subtracting. So even if you have 100 m square terms, only 1 m square will come in the sum or the difference.
Over here at the top it's written minus 5m square and here it's plus 5m square.
Oh, Yengama, or maybe where? Oh yeah, sorry. Thank you, Aishwarya, by mistake.
Yes, ma'am.
Yeah. Thank you, sorry. Yeah. It's minus. Sign marad, it's minus. We are not transposing, no, we are not taking it by mistake, sorry. So we are not taking it to the other side of something. We are not transposing. This is not an equation, it's an expression. Okay, so 15m, then this minus 13m, minus 5m square plus 6m square. So 15m minus 13m is 2m. And this one different sign, subtract 1. Sign of the greater number is plus 1m square or simply plus m square. Minus 5m square plus 6m square. Different signs, subtract. So 6 and 5 when you subtract, you get 1. And put the sign of the greater number, plus. 1m square is nothing but m square. You don't have to show that 1. Don't write 1. It's just m square. Yeah, go through this one, children, and let me know if you have any doubt. This is the next one. This is the next one. Add. See if I should explain anything. What are you discussing? It's basically this into this, correct? 12y cubed. 20y squared. Because 4y into 5y. 4 5s are 20. Y into y is y to the power 1 into y to the power 1. 1 plus 1, 2. So y squared. What is y plus y, children? What is y plus y? 2y, because it's 1y plus 1y. 2y. 2y. Y plus y is 1y plus 1y. 1 plus 1, 2. 2y. But y into y is, add the powers. 1 plus 1, 2. So you'll have to multiply all these three terms with 4y outside the bracket. And 4y is positive. This one is positive. This 3y square also, this is positive here. But you don't see the sign there, which means it's positive. So how do you, so it's basically multiplying plus 4y and plus 3y square. Then you're multiplying plus 4y and plus 5y. And then plus 4y and minus 7. Correct? In the first bracket. So multiply the signs, plus, multiply the numbers, 12, multiply the letters, y cubed, multiply the signs, multiply the numbers, multiply the letters, multiply the signs, multiply the numbers, multiply the letters. So you can see this first term, plus 20y square and minus 28y. Same thing with this part. And then you have like terms, so simplify them. Yeah. Subtract. All right. Yeah. Online students, so which one to write first? So now this one is not the vertical method, children. Like you understand why from the way the question is. 3pq into p minus q. That has to be simplified. So you cannot do it in the vertical method. So it is horizontal. Sorry, yeah. So which one to write first?
The first term should be written as 2pq, the 2pq multiplied by p plus q.
Yeah, then we have to write 3pq and 3pq into p minus q. Separated by what sign? Minus.
Minus.
Why? Because subtraction. Yeah, minus. Now multiply these two. 2p square q. Multiply these two. Plus 2pq squared. Now minus into plus. See, this one is minus 3pq, children. Minus 3pq into p. Minus 3pq into minus q. Multiply the terms along with their signs. Don't forget the signs. This is minus 3pq. In the second part, you have to multiply minus 3pq. Minus 3pq, you need to multiply minus 3pq with the first term plus p and the second term minus q. So what's the answer? So it is minus into plus minus 3p square q. Then minus into minus plus, minus into minus plus 3p q square. 3p q square, because q into q is q square. Now we do have like terms p square q, p square q, p q square, p q square. Yeah, we have like terms. So 3 minus 2 is minus 1. Minus 1 or simply minus p square q. And this one plus 3 plus 2 plus 5 p q square. When you're adding or subtracting, please simplify only the numbers. Do not do anything to the letters. Write it as it is. When you add these two, see, these are like terms. When you add them, the result is also a like term. See here. Now these three are like terms. PQ squared, PQ squared, and you add, you will get another PQ square only. Only the number, the coefficient will change. All this you can do. Multiplying. Yeah, Harsha. Can you answer this, Harsha? Okay, so this step is optional, children. This is optional. You can write 2 into 4. Like you can just collect the numbers and write it first, and then into a square into a to the power 22 into a to the power 26. It's a product everywhere. It's multiplication everywhere, no? See, you can give more steps. Like you can write a square into 2 into a to the power 22 into 4 into a to the power 26. This is the meaning. Now, in this further, you can write 2 and 4 first. And then write a square, a to the power 22 and a to the power 26. Now, this is further 2 further 8. And when you multiply all these three, you will get a to the power 26 plus 22, 48 plus 250. That's all. Online students?
Yes, ma'am.
Yeah, is it any clarifications here? Clear? Or any questions?
No,
No,
ma'am,
ma'am.
clear.
Okay. So in the second one, multiply the numbers first. 2 by 3 into minus 9 by 10. See, it's a monomial. This is a single term. This one is it's a single term. This one is a single term. This one is a single term. These are single terms, children. See here. This one is a monomial. This one is also a monomial. So how do you multiply? Multiply the numbers. Then x and then y. Not able to focus. Multiply the numbers, multiply the x and x square, then y and y square. You can cancel 2 ones are 2 fives are 3 ones are 3 threes are. So minus 3 by 5. And when you multiply this, you get x to the power 3. When you multiply this, you get y cube. You can ignore the multiplication sign in the middle. You need not put this. That's all. So I think I have shown steps to, yeah. One. Did you understand this one, children? The second one?
Yes, ma'am.
Yeah. See the third one? So it'll be minus 10 by 3 into 6 by. See, they are monomials, children. You're multiplying a single term by another single term. So multiply the numbers minus 10 by 3 into 6 by 5. Now multiply the letters into p into q cubed into p cubed into q. So p into p cubed is p to the power 4. Q cubed into q is q to the power 4. And here 3 ones are 3 twos are 5 ones are 5 twos are 2 to the 4 minus 4. What's the answer for the last one, online students?
It's x to the power 10.
Anantika? You're not there, Anantika?
Ma'am, I'm here.
Yeah, answer for the last one.
Can you repeat? Your voice wasn't clear.
Since when my voice is not clear?
It's cutting at the moment. Hello?
Okay. No, you're not audible to me. Yeah. Now, okay, tell me which one are we working on?
Ma'am, your voice is cutting constantly. I don't know why.
But you didn't mention this earlier to me.
It was fine before, but in between, I don't know, now it's getting cut.
Okay, so my concern is, are you following?
Yes, ma'am.
Okay, I was asking you the answer for the last one.
X raised to the power 10.
X raised to the power 10. Oh, okay, very good. Yeah. So here you have to simplify. Please understand the question. We'll have to simplify this and then find its value. Find the value. After simplifying, find the value when x is 3 and x is 1 by 2. So how do we simplify? We have two subdivisions. The first one is this one. This is the first one. Now we need to first simplify this. Simplify means open the bracket. 3x into 4x, 12x squared. 3x into minus 5, minus 15x, plus 3. We have simplified. Now, when x is half, I'll do the second one. When x is half, 12 into 1 by 2, the whole square, minus 15 into 1 by 2, plus 3. Do not cancel. 2 1s are 2 6 are is wrong. Because 1 by 2 is raised to the power 2. Simplify the power first. The exponent has to be simplified first. You cannot cancel. Yeah, 1 by 2 the whole square. Simplify that first. So that will be 12 into 1 by 4 minus 15 by 2 plus 3. Then now 4 ones are 4 threes are. And 3 ones are is 3. 3 minus 15 by 2 plus 3. Then after this, you know, LCM and all that, we'll get it. 3 plus 3 is 6. 6 minus 15 by 2. So that's what is the meaning of this question. Simplify. So first work, meaning open the bracket. Remove the bracket by multiplying. And then apply the values of the variable given. A0, A1, A minus 1. So you're finding the value of the expression for some specific value of the variable given. For some specific value of the variable given, you're finding the value of the expression. That's about this one. Yeah. So how do you add these children? Somebody online tell me. Next one is for you. Yeah, somebody online, please answer this question. Are you there, Sai Smriti?
Yes,
Sai,
ma'am.
I mean, yeah, then tell me.
Yes, ma'am. Can you show me the question?
Quick.
Yes, ma'am. P square minus P cube.
How should I start? P into P minus Q plus Q into Q minus R plus R into R minus P. Because we'll have to add, no? So connect the terms, connect the expressions with a plus sign.
Okay,
Now,
ma'am.
yeah,
P square minus P cube.
faster.
Yes, ma'am.
Mhm.
Plus Q.
Yeah, go on. Yeah.
Plus Q square minus QR plus R square minus RP.
Like terms? Do you find like terms? to be simplified further?
No, ma'am.
So that's the result. This is the answer.
Okay, ma'am.
You must write this, children. You must write the expressions given and connect them with a plus sign. That indicates you're adding. You should not put the comma and write. Write the first expression plus. See, the comma should be replaced with a plus sign. The sign should become plus. And then equal to. So same thing, no? Add, okay? Subtract. So tell me, how do we do this? So the, subtract this and this. அப்படின்னா இதே orderல தான் எழுதணும். Why? Because subtract this and this. From இருந்தாதான் from க்கு அப்புறம் இருக்கிறத first போடணும். This is subtract 10 and 3. 10 minus 3, 7. Subtract 3 and 5. 3 minus 5. Same order you should take. Same order. Because there is no from here. Same order. That means 3L into L minus 4M plus 5N minus 4L into 10N minus 3M plus 2L. So this is the first step. So that's equal to 3L square. Next, yeah, so, yourself. Faster. Sign சொல்லணும் first. Minus. அப்புறம் number சொல்லு. 12. அப்புறம் அந்த letters. LM. அடுத்தது sign. Plus. அப்புறம் number. 15. அப்புறம் LN. மறுபடியும் sign. Minus. Number. அப்புறம் letters. LN. Sign. எப்படி minus? Minus into minus plus. Plus. 12. LM. அடுத்தது sign. Number. Letters. Or letter. L square. Are there like terms? Yeah. 3L square minus 8L square. What's answer? 3L square minus 5L square. Minus 12LM plus 12LM. 0. So you can cancel that. Then plus 15LN minus 40LN. Minus 25. Minus 25 LN. Yeah, we'll wind up today's session with this one, children. Please hold on. With this, we are completing exercise 9.1, 9.2, 9.3 from NCERT. We still have 9.4 and 9.5. Exercise 9.5 from NCERT is all about algebraic identities. 9.4, we finished 3. Out of 5, we finished 3 in today's class. We have 9.4 and 9.5, of which 9.5 is about algebraic identities. All right. All right. So here it is subtract. Children, see, subtract this one from this. Yeah, but you know something? This itself has to be simplified, no? This itself has to be simplified. So simplify that first. That itself has to be simplified. See here, 3A into A plus B plus C minus 2B into A minus B plus C. This itself has to be simplified. So let's work on this first. So 3A squared plus 3AB plus 3AC minus 2AB plus 2B squared minus 2BC. Correct? Now simplify this. 3A square will come as it is. 2B square as it is. There is one AB and AB term here. So plus AB. Plus AB. Then minus 2BC and plus 3AC. Now this is the answer. For this one, we have the answer here. This one, this is the answer. Now you said from. Now in step 2, right, what is after from? 4c into minus a plus b plus c. And then here we have 3a squared plus 2b squared plus ab minus 2bc plus 3ac. Now you subtract. So you should put all this in a bracket. Because whenever you're subtracting, after the minus sign, if there's more than one term, put them in a bracket. See, this is what is after from, no? After from we have this one. Sorry, this is what is after from, right? After from we have this one, right? This one was before from. So put this in a bracket and then subtract, take a minus sign. So it'll be minus 4ac minus 4bc plus 4c squared. And here the signs will change. What will it become? Minus 3a squared minus 2b squared minus ab plus 2bc minus 3ac. And then so you have so many terms. Now look out for like terms, simplify, and that's the result. All right. Alternatively, you can work this one. See, what you can do is we already worked this one. You can also work this one. So you can simplify this expression, meaning multiply, bring them out of the bracket. So you can simplify this one and this one, and then also in step, so you can work this in step 1, work this in step 2, and in step 3 you can write this answer minus this answer. Work this one in step 1, work this one in step 2. In step 3, whatever result you got here minus the result you got here. But put the results in brackets and connect the brackets with a minus sign. And then again, like terms and result. All right. All right, online students and offline students. So I have some more instructions to share with you regarding the classes, which will be given on WhatsApp. So today or tomorrow, I'll be updating some changes and some things which you should know about the further classes. So please check WhatsApp to get the information on the same. All right. Yeah, now again acknowledge Sai Smriti, are you there? Anantika and Aishwarya?
Yes, ma'am.
Yes, ma'am.
Aishwarya?
Yes, ma'am.
All right. All right, children. So that's it for today's session. Thank you so much. Online students can leave the call. Thank you.
Thank you.
Thank you, children. Thank you, children. Sorry?